In this video, we want to talk about how to find a difference quotient. So what is a difference quotient? A difference quotient actually is defined as this. If you have a function we call fx, equal to fx, and the difference quotient is defined as the following. So here, f of x plus h minus f of x divided by h there. Okay, this difference quotient is very useful expression, and we're gonna use in the calculus. Okay, so now and let's take a look here. So how we're gonna find the difference quotient? So we use a specific example here. First, we have a function. That function is a polynomial, a quadratic function. And we want to do a little bit more than just evaluate the difference quotient. Okay, let's take a look. First, we want to evaluate a function f of -2. So that equal to, and remember, f of -2 means you replace all x in the function by -2. So it turns out you have -2 times -2 squared plus -2 and minus 1. So now all you need just follow the order of operation to evaluate the function. So here we got -2 squared, because this involves exponential expression, you need to evaluate that first. -2 squared actually equal to 4. And plus -2, you can just change this as -2 and -1. So now you can see here I have -8 -2 -1. So put us together, combine together is -11. Okay, so that's what we have here. Evaluate a function. But sometimes we may want to evaluate a function and add 2x, add a specific variable there. It's not add a specific number there, but involve variable. But there's no problem. It's still same as what we did earlier. F of 2x means you replace all the x's in the original function fx by 2x. So here you have -2. You replace this x by 2x. Replace this x by 2x. Okay, so here what we have there, same as before, you need evaluate exponential expression first. 2x squared, which is 4x squared. 2x times 2x, which is 4x squared, plus 2x minus 1. So that's multiply. So -2 times 4 is -8x squared plus 2x minus 1. Okay, so that's what we have there. And before we figure out the so-called, we call this difference quotient, let's evaluate f of a plus h. And now it's getting more interest there. And sometimes people think f of a plus h, is that equals f of a plus fh? So here, is that equals fa plus f of h? The answer is no. They are not equal. Okay, they are not equal. Most time they are not equal. Some special kind of function, maybe you have fa plus h equals fa plus fh, but normally they are not equal. Okay, so how are we going to evaluate this? F of a plus h, same as before. You replace all x by a plus h. So you have a negative 2a plus h squared plus a plus h minus 1 there. Okay, and so let's expand it. And also, that's part, a plus h squared is not equal to a squared plus h squared. This is also very common mistake. People think a plus h squared equals a squared plus h squared, which is not. Okay, because this is a so-called perfect square. If you want, okay, get expanded this, you have to use the FOIL. Okay, so you got negative 2. When you use FOIL, so which means you have to do a plus h times a plus h. You got a squared and a squared and ha, which is h squared and plus a plus h minus 1. Okay, so here that one you can write this as and a plus h, ah plus ah, so that's you got 2ah. So here I got negative 2a squared plus 2ah plus h squared plus a plus h minus 1. Okay, so here, and if you want, distribute negative 2 to each of them, you can. You got negative 2a squared minus 4ah minus 2h squared plus a plus h minus 1. And remember here, when you do distribution, make sure you distribute to every term. Negative 2a squared, okay, negative 4ah, negative 2h squared. Okay, so now we evaluate f of a plus h, which is this here. So now we are ready to evaluate f of a plus h minus f of a divided by h. So this equal to f of a plus h. We already got this here. Okay, so we're going to copy those whole thing there. Negative 2a squared minus 4ah minus 2h squared plus a plus h, there's no square. Okay, minus 1. And so here, minus f of a. F of a means you replace this x by a. Okay, so because you match the whole f of a. So make sure you put the parenthesis negative 2a squared plus a minus 1. You replace x by a there. Okay, so now, and so we're going to simplify the numerator. So here we have, that's part we can't simplify because no like terms you can combine them together. But we want to get rid of this parenthesis so we can combine like terms here. Negative 2a squared minus 4ah minus 2h squared plus a plus h minus 1 and minus, okay, when you drop the parenthesis, because in front you have a negative sign, when you drop the parenthesis, you should change the sign for every term inside of the parenthesis here. So that means negative, so that's changed to positive 2a squared. And that's changed to minus a, that changed to positive 1. So really that you consider this is negative 1 to multiply each term. Okay, so now you can take a look here. The like terms, negative 2a squared, positive 2a squared. So that's two terms canceled. And you have a, and you have a negative a. That's two terms canceled. Okay, and you have negative 1 and a positive 1. So this you canceled. with this. Okay, so now let's take a look at what is left. What is left is negative 4ah minus 2h squared and h divided by h there. And remember, when we evaluate this, you have to simplify this here. And now, this is another common mistake people always make there and say, oh, look here, can I reduce this h with this h? Can you do that? Oh, can you reduce this h with this h or with this h? Okay, the answer is no, you cannot reduce the h with one of them. You can't reduce h with one of them. Okay, the reason is in order to reduce a common factor, the numerator denominator must be in so-called factor form. Factor form. Right now, the numerator is not in the factor form, so you can't reduce anything. Okay, so in order to reduce this h there, so let's take a look at what we're going to do here. And we find the common factor, which is h in the numerator. I go ahead and factor out the h from the numerator. I get h squared h. So I factor out the h. The first term, I got negative 4a left. The second term, I have a 2h. The last term is 1 divided by h. So now I reduce the h. So now I have, let's reduce, that becomes 1. So here, negative 4a minus 2h plus 1 divided by 1. Okay, so that means we can just rewrite this as negative 4a minus 2h plus 1. So now we are done to evaluate the difference of a quotient, like difference quotient. Okay, and although we may have different problems, okay, but the method was all same there. Okay, that's video.